Good day, everyone. Good day, my friend. Okay, let me introduce myself first. My name is Gilang Ramadan, and I'm from the Bilingual Physics Education Department, class of 2022. Okay, on this session, I will tell you all about the phenomena in physics lessons. Okay, check it out. Okay, the first kinetic energy. Kinetic energy is the energy possessed by an object due to its motion. Here are the general steps that describe the phenomenon of kinetic energy. Moving objects. Objects must be in motion to have kinetic energy. The next, calculate speed. The speed of the object needs to be known. Kinetic energy is a function of the speed of an object. Okay, the next, calculate mass. The mass of an object also affects kinetic energy. Here, objects have more kinetic energy at the same speed compared to the lighter objects. The last, calculate kinetic energy. This is the kinetic energy formula. Okay, E equal to a half m times v squared, where m is mass and v is velocity. Okay. The next there is potential energy. Potential energy is the energy possessed by an object due to its position in a force field, such as a gravitational field. Here are the general steps that describe the phenomenon of potential energy. Okay. Objects are in a force field. An object is placed in a force field, such as Earth's gravitational field. The next object moves. The object is moved in a force field. This could involve lifting an object in a gravitational field, compressing a spring, or moving an electric charge in an electric field. Okay. Energy workout. Energy is work to move objects. This energy is stored in the object as potential energy. Okay. And the last, potential energy. The object now has potential energy due to its position in the force field. If the object is then released, for example, the object falls in a gravitational field or a spring is released, this potential energy will be converted into kinetic energy. Okay, next, mechanical energy. Mechanical energy is the sum of kinetic energy and potential energy of an object. Here are the general steps that describe the phenomenon of mechanical energy. Objects are in a force field. An object is placed in a force field, such as Earth's gravitational field. Object move. The object is moved in a force field. This could involve lifting an object in a gravitational field, compressing a spring, or moving an electric charge in an electric field. Energy worked out. Energy is work to move object. This energy is stored in the object as potential energy. Moving object. The object that moves, converting some or all of its potential energy into kinetic energy. Mechanical energy. The mechanical energy of an object is the sum of its kinetic energy and potential energy. If there is no friction or other outside force, the mechanical energy of the object will remain constant, or law of conservation of energy. Okay, regular strike motion. Regular strike motion is the motion of an object whose trajectory or path is in the form of a straight line and its speed is constant. Here are the general steps that describe the phenomenon of regular strike motion. Okay, resting object. The object is initially at rest. Style application. A force is applied to the object. This force can come from various sources such as gravity, human power, machines, and others. Moving object. Due to the force applied, the object begins to move. The speed and direction of movement of the object depend on the magnitude and direction of the applied force. Okay, the last, regular strike motion. When an object moves at a constant speed and a strike trajectory, this is called regular strike motion. Okay, strike motion change regularly. Strike motion change regularly is the motion of an object whose trajectory or path is in the form of a strike-like line and its acceleration is constant. Here are the general steps that describe the phenomenon of strike motion changing regularly. Okay, resting object. The object is initially at rest. Style application. A force is applied to the object. This force can come from various sources such as gravity, human power, machines, and another. Moving object. Due to the force applied to the object begins to move. The speed and direction of movement of the object depend on the magnitude and the direction change regularly of the applied force. The last, strike motion, changes regularly when an object moves with constant acceleration in a strike trajectory. This is called strike motion changing regularly. Okay, next, the first law of thermodynamics. The first law of thermodynamics, also known as the law of conservation of energy, states that energy cannot be created or destroyed. It can only be changed from one form to another. Okay, there is the flowchart from the first law of thermodynamics. Thermodynamic system. A thermodynamic system is defined. This can be an engine, gas in a container, and etc. Energy in. Energy is a fed into the system. It can be heat, work, or other forms of energy. Energy conversion. Energy fed into the system is converted into other forms. For example, in an engine, chemical energy from fuel is converted into mechanical energy. Energy out. Energy out of the system in another form. For example, in an engine, part of the mechanical energy is converted into heat that is released into the environment. Okay, conservation of energy. The total amount of energy in the system, or internal energy plus incoming energy and minus outgoing energy, remains constant. Okay, there is force. Force is an interaction that causes a change in the motion of an object. Here are general steps that illustrate the phenomenon of force. Objects at rest are moving. An object is initially at rest or moving at a constant speed. Style application. A force is applied to the object. This force can come from various sources such as gravity, human power, machines, and none others. Change in motion. The two parts apply to the object undergoes a change in motion. This can be a change in speed, or acceleration or deceleration. A change in direction or both. Newton's law. This change is governed by Newton's law of motion, which, among other things, states that the force applied to an object is equal to the mass of the object multiplied by its acceleration with formula F equal to m times a. Electric current. Electric current is a difference in electric potential between two points in electrical circuits. Here are the general steps that describe the phenomenon of electric voltage. Okay, electric current. There is electric source such as a battery or generator that creates in electric potential difference. Electric circuits. Electrical circuits are made by connecting components such as resistors, capacitors, and others using electrical connecting wires. Electric current. Electric current. When the circuit is closed, an electric current begins to flow from a point with high potential to a point with low potential. And the last, there is voltage. Electric voltage is measured as the potential difference between two points in a circuit. This is the energy needed to move an electric charge from one point to another in the circuit. Okay, that's all about my theory. Phenomena of physics in the form of flowchart. Okay, I hope you understand what I mean, and see you.